Good afternoon, everyone. Thanks so much for spending your lunchtime with us. My name's John, and we're going to walk through a short presentation. A question I get a lot, and what we're hoping to just shed some light on today is how can I get a return on my investment in 3D printing technology? Essentially, what's the business case for 3D printers? I'll be doing my best to manage the chat room and the questions as we get going. If you do have a question, you're having trouble hearing, please by all means just maybe type something in the chat room and we'll do our best to remedy any problems that we've got. If you've got some questions, type them into the questions area, and towards the end of the presentation I'll go back through the questions and answer as many as I can along the way. So without any further ado, let's jump right into it. So in order to answer those questions today, there's a few key topics we want to go through. We want to look at some cost reductions, of course, making money by driving more sales or improving your close rate on business, or maybe reducing your loss rate. We want to understand the business impacts of supporting the manufacturing with a 3D printer. There's huge impacts we can have to reduce costs and save time in 3D printing. We also want to look at the cost of rework and evaluating your return and comparing it. Let's try to come up with some actual numbers today compared to some traditional methods. So that's what we've got. In order to accomplish the goal, we've got lots of financial information from other companies that we work with, but of course it is proprietary. So what we're doing today is defining somewhat of a fictitious company so that we can go ahead and come up with some numbers. So we'll look at three case studies that are typical out there to understand the impacts of what they've seen, and then we'll apply the impacts of the studies and sort of visualize and calculate with actual numbers what our savings are. So a bit of a visual look at this, and then some hard look at some numbers. So in terms of the company that we're going to use for our fictitious case study today, it's the Custom Equipment Company. And these folks have got 3 engineers. They've got about 10 people in manufacturing. When they install a piece of custom equipment, they send 3 people out. Traditionally, for the size of equipment that they're working on, let's just say that they've got about a 16-week process. And when we go ahead and envision what that process looks like, it's going to be very typical. They work on winning some contracts, they design, they manufacture, they install, and then they go back and they document the overall process. For this particular view, we are going to look at a bit of a linear process. I do know that some of these things obviously overlap and happen in parallel, but for the sake of just keeping it simple, we'll look at it this way. So some of the things that happen throughout this process are they evaluate the design, they evaluate their manufacturing, and they evaluate their assembly options. They've got to make some parts and buy some parts, and then they've got to make some tools to support the manufacturing and assembly. So those are some of the key areas that we'll dig into throughout the process. As a first step, the Custom Equipment Company makes one-off pieces of custom equipment. And although many pieces of custom equipment have things that you would never dream of 3D printing because they're just readily available, big metal extrusions and rollers and things like that, there always is a heart to the design. There's some place in that design where there's a level of complexity, and we're not really sure exactly what the best way to move forward with the design is. So to highlight the impacts of prototyping in those areas, I chose the heart and soul of an agricultural product. It's the seeder. So you'll have a big giant piece of farm equipment roaming across the land, but really what makes the money, what makes the crops grow, is this particular gizmo. And in this particular case, the White's Planters 9000 series, it's cost prohibitive and time prohibitive to prototype traditionally. The shapes of the seeds vary and the size of the seeds vary. So that makes it really hard to figure out exactly what this thing should look like. And at the same time, you need a product that's going to be reliable and maintainable through long periods of in-use over winter months, and then high periods of use during the spring planting season. So by introducing 3D printing into this process, and you can see from the quote there, to make an aluminum prototype, so our traditional costs, our traditional methods, whether we're outsourcing or doing these things internally, somewhere between $5,000 and $7,000 per version of this. When they looked at doing it in plastics with a 3D printer, those costs came down to $1,000 to $2,000. When we start to compare those different numbers, what we'll see for this particular organization is they saved up to $5,000 per prototype, and that's anywhere between a 40 and 70% reduction in costs. A really interesting thing is that they're able to evaluate 5 prototypes in 5 weeks because of that cost, instead of 1 in 7 weeks, which is about an 85% improvement in terms of time. Now, when they did all those evaluations in such a compressed period of time, they picked the best direction to head on their designs. They ended up with 70% fewer parts, and this had a reduced maintenance schedule. So the farmers and the growers that were using this equipment liked it because they had to spend less time on it. It resulted in a long list of new features for the farmers, so it had a really good market impact. Their sales were high in the product. Another impact of reducing the number of parts in the product is that it's easier and takes less time to assemble. So you've got a spin-off benefit on that. So there's one look at why prototyping is important in the process. Let's talk a little bit about jigs and fixtures and trying to understand some of the aspects or some of the benefits of 3D printing on the shop floor, be it the support of the shop floor or giving engineers, designers, and other people inside the company a different way to make things that doesn't impact skilled trades, laborers, and existing equipment on the production shop floor. So I'll let you take a minute to have a look at that drawing on the screen and maybe think about how you might make it if you're an engineer, or how your company might make it if you're a business owner or a manager. We've got a couple of small plates that go together. The overall size of this thing would fit in your hand. It's not a giant piece, just a couple of aluminum plates that go together. And I guess what I would say is, there's lots of different ways that you could make it. I'm going to highlight maybe how a larger company would go ahead and do that, so we can see how 3D printing just unlocks the innovation, the creativity in various areas of the company, and saves time and money at the same time. So we'll contrast or compare all the steps it takes to build this thing traditionally. And like I say, I'm going to use more of a medium or a larger size company for this this particular example. Of course, if you're a smaller company, you might just go to somebody and they might pull some parts out of the junk pile to make it. But we're going to look at the other direction today. So you need 4 part numbers to make this thing. So you've got to pull those. You need 3 part files, 1 for each plate, top, back, and bottom. You need an assembly file to assemble the 3 part files inside of SOLIDWORKS. And then you've got to create 4 different drawing files so you can communicate your design out to the shop floor so they can make this for you. In order to actually flame cut or route different things, you'll need 4 DXF files as well to send out to manufacturing. So you've got a couple of hours of design work up front to pull this thing together and get it organized to get it out to the shop floor. And then you've got to manage all that data if there's design changes. You've also got to check your inventory. Maybe you got to go talk to purchasing, see what they've got on order. So it's another touch point. If you're a medium or large size company, you might have some sort of an ERP tool that you need to route this particular project through the shop floor. So you've got to load information there. You need some 3/8 inch things cut. So you got to wait for the 3/8 inch aluminum plate to get loaded up onto the router table. It gets routed. Some parts get put in inventory. The 1/4 inch plate gets routed, put in an inventory. Magically, a couple days later, somebody comes along and drills, taps, assembles, and you get an assembled fixture on your desk after a week, 2 weeks, 3 weeks, whatever the case may be, for this to work its way through the shop floor. So you've taken up a couple of weeks. You've had to manage the project. You've also had to interrupt or use 3, 4, or 5 other human resources, other people inside of the organization. Let's look at the 3D printer version where it's a task. You pull 1 part number, you design that in SOLIDWORKS, you save it out as an STL file, you print the part, and then you're done. So this is a task is something you can come in and get done in the morning. A project is something you need to come back to over the course of a number of weeks. So here you get a sense, when we talk about a 40 to 70% labor savings, time savings, cost savings, these are the reasons why, and it's really key that we understand some of those things. So the actual case study on this particular jig and fixture is that it's a 40 to 90% lead time reduction. It's a 70 to 95% cost reduction, and this is typical across the board in the jigs and fixtures areas. These are numbers that come from a cross section of companies. there are some spin-off benefits, and do not overlook these. When I go to 3D printing, I don't need to create detailed drawings. I don't need to manage those detailed drawings. I can minimize my PO and payment requirements. It's a task, not a project, like we'd said before. And then here's some other interesting ones. There's a reduction in storage space. I don't have big, heavy fixtures that I need to store, and it's not difficult to move them around. People can pick things up. Quick replacement or revision. Because I can print it in a couple of hours without disturbing the rest of the organization, if I have an idea to make this jig or fixture better, I can reprint it, or I could make 2 of them if I needed to do so very easily. So this is an area where you can look at some improvements. Here's another one we want to look at as you start to engineer that can have big impacts when you change your mindset. And these are some areas where depending on where you may be at in your engineering career, you may want to go back and look at some courses. I know that we're writing some courseware to help people start to think differently in terms of 3D printing and additive manufacturing. Traditionally, we've been trained as OR engineers, but going forward, we're going to see more AND engineers. And once we go through this, it's pretty easy to understand. Historically, things could be ergonomic, curvy, and swoopy, or they're easy to make, rectilinear, round, square. It could take very little time to make it, or it could have a low cost, or it could be light and strong. So we have to make balancing decisions in the OR engineering process. As we move over to AND engineering, we can be ergonomic, and it can still be easy to make. There'll be no labor, and it'll be low cost, and we can still make it strong because we can put the material, we can put the plastics where we need them, not where they're left in the traditional process. And we can customize just about everything. There's no cost or time hit for adding custom components to this. We'll have a quick look at the example that highlights the impact of some of the things we just talked about. So we'll look to our friends in Germany, the boys and girls over at BMW, and they made a particular jig, and you can see it on your screen. And this particular one, and I apologize, it's a bit grainy, it is used to put the M3 badge on the back of the automobile. If you have a look at it and you think back to the other jig or fixture that we made with just a few parts, expand that out into maybe 15 or 20 components, and it's a mix of purchased and assembled parts. In addition, start to think about how the operator feels, those skinny little wire handles trying to hold this jig, and this weighed about 25 pounds. So you do this all day long, lift it up and put it in there, and start to compare. So their cost and time requirements are high. It's about $400 in 18 days to get a new one of these made. And because of the parts that were, the raw materials that were typically in stock, they really lack design freedom, and which can reduce productivity. The solution was to redesign this jig with an organic shape that made it easy to use. We can also print it somewhat hollow in the middle, so it has a sparse fill, so we're able to reduce the weight by 72%. By doing so, we come up with a new design, and we reduce our typical lead time from 18 to 1.5 days. But the really interesting thing, and you have to just give this some thought when you start to put together the ROI, if I can reduce health and safety costs by 1, imagine lifting up 25 pounds 100 or 500 times a day, your arms are going to get tired. So you might have a repetitive strain issue lurking on the shop floor. In this particular case, what they found is at the end of the shift, workers were scratching the cars accidentally because their arms were tired. So by 3D printing this jig, yeah, they saved $300 and they can get it built 92% faster, but there's less rework and cost going onto the assembly line. So to think about those out-of-the-box type of issues as well. So let's just quickly summarize those benefits, and then we want to get into the heart of this, the actual numbers. So we've got cost reductions, lead time reductions, we're addressing health and safety issues, we're building strong customer value propositions, and we are having a direct impact on manufacturing because we're putting less parts together. So we've got our summary of benefits. Let's go back over to our fictitious customer that we're looking at. Excuse me. And start to come up with some numbers. So let's visualize our ROI again. Here's our 16-week process. Now, I'm not sure about any of the projects that you personally work on, maybe at your homes or maybe at your place of employment, but all my projects go longer than I intend typically. So the 16-week project you're planning for sometimes extends out to 18 weeks. If we look at reducing that and just keeping it on track, there's an ROI there, and that ROI is a risk reduction ROI. So what we're talking about here is introducing a 3D printer into this process somewhere so that when we're surprised, that 3D printer gives us a very agile, quick, easy way to go and make a part to solve a problem and keep the process moving forward. What we want to do is actually shrink this design time down from 16 to 14 weeks. And we'll talk about where we're going to do that. So what we're going to arbitrarily say is that based on the statistics that we previously saw, 40 to 70%, 80 to 90%, some very big numbers, those are almost unbelievable numbers. And 3D printing can't be used everywhere. We have to kind of be realistic about where we're going to use this technology and fit it in. So for sake of being realistic and picking some easy numbers, I'm going to pick 12.5%. So I'm going to take all those 40s, 50s, 70, and 90%, and I'm just going to bring them right back down. And that 12.5% against our 16-week process takes 2 weeks out. So we're looking at taking about a week out of design and a week out of manufacturing. So now that we've got some numbers there in terms of what we think we can reduce our cycle on and base our time and cost savings on, let's apply that back over to the number of people we've got working on different areas. We know that on the design side, we had 3 people working on things. And what we're going to do with prototypes, the benefits of prototyping are improved communications. And as we improve communications, we're going to pre-prove out ideas. We'll sit with the sales and marketing guys and the high-level design teams. We'll have faster decision making. If you're only doing one prototype or maybe one design and then moving forward with it, you're potentially missing areas that you would have liked to have explored. So you want to print out 4 or 5 different prototypes very early on in the process. Pick the right one, and you're going to have less downstream errors. And that's why you'll see those numbers of cost savings and time savings. For those of you who run a CAD station, you'll often design yourself into a corner, and then you've really got nowhere left to go without adding complexity or cost unless you move back to the beginning and take a different path. So those are the things that can be avoided with some early prototyping. So looking at the 3 people per hour on a project in design, 3 people at $50. If we can take a week out of design, we can save about $6 grand. It's not a lot, but it's a start. So let's move over in manufacturing and look at some of those same things. And we can, I'm pulling the summary information out. 49% lead time reductions, 58. Those numbers are transposed. I think it should be 55 to 85% cost reduction and 70% less parts in the design. Those are some typical benefits. So when you get to manufacturing, you've got a pre-proved out process. There's no surprises during the assembly phase because manufacturing was involved early on with parts in their hands saying, yes, I can put it together that way. Yes, that hole's in the right spot. So I can reduce rework. Now, if you might have a budget area in your finance department, you can go and talk to them about what their rework costs are, and maybe you could get a number, pick a number based on what finance is tracking. You can address health and safety concerns. There's always surprises that come up, and what you just want to have is that special magical tool that just gets you out of a tough spot, and that's what 3D printers can do. So when we look at some of those same reductions, 10 people at $50 per hour, you're going to save a number of hours because there's more people involved in manufacturing. It's a bigger hit. It's about $20,000 that we're going to save through that part of the process. Let's take the next step. If you can get this machine built in time and ship it on time, the installation is going to go a little better because you're not doing final assembly on site where it's very expensive. So I just added a little bit here, not too much, but with simpler designs and having things on track and maybe even practicing on 3D models that you've printed out, you could do some mock-ups. Maybe you have a slight impact. Oops, sorry. Maybe you'll save a little bit of time on site, and maybe you'll save a little bit of costs and travel where you don't have to stay at hotels and eat as much food. So let's convert our per project savings of about $27,000, $28,000 on a project, a 16-week project, and move that over to our full year costs, assuming it's a 52-week year. We can do 4 projects. So just based on the numbers that we've calculated so far, we've got an annual cost savings of about $100,000. So the numbers start to add up pretty significantly in a medium-sized business. What we haven't looked at yet is an increase in capacity. So we've taken 2 weeks out of every project. That's going to leave us over 4 projects. We have an extra 8 weeks in the year. So we can potentially do an additional half of a project, which adds about another $14,000 through there. So we've got a cost savings of half a project as well. Now this one's a bit tricky in terms of an increase in profit. What you have to imagine here is that we've actually reduced the rework budget on top of all the other things that we've talked about, or because you can deliver that machine faster and on time and as promised, you'll be able to charge more for it and you can increase your profits. So profitability can go up as well. And that's what we're adding in with the $24,000. There's also the risk reduction side of it. So if you go ahead and you look at what those risk reductions might be, that's really up to you if you want to calculate those in there. But if you can remove those unforeseen costs, you can take those out as well. The increase in profitability, if you want to find out more about how that number is calculated, I can share that with you in a follow-on conversation. So if you look at these numbers with just a very simple stroke of the brush, we're very close to a couple $100,000. So a desktop printer at $20,000, $30,000, $40,000, you know, certainly pretty straightforward to justify. As you start to get into some larger purchases, if you wanted to do some things, the ROIs are there. They would of course need some actual numbers from your organization just to make sure that that purchase was a good one for you. We haven't covered everything here today. Obviously there's other areas. So some other considerations are inventory and space costs, penalties and holdbacks if you don't deliver your project on time. Some industries suffer a 10% holdback or you know, a single-digit percentage penalty for not delivering on time. 1, 10, 100, 10,000. The cost of fixing errors, as we all know, just goes up the further along it gets in the manufacturing process. So 3D printing can help us minimize errors along the way. There are specific applications such as molds and sheet metal stamping. So there's ROIs that could be related to those. Warranty cost reductions, time to market is an area. Lost business is one that we see and start to see a lot more of out there. And what we're starting to see, in fact, is that people are requiring, it's a must-have item to bring a 3D printed replica of what their proposal is if you're manufacturing something, or at least something that will describe how it works. And what I would say is that companies who aren't doing that today are potentially losing large contracts, and we're working with some of those companies today. And here's a bit of a look back. It used to be good enough to bring black and white drawings of what it looked like, and then we needed to bring full color sales proposals. As we transitioned from 2D AutoCAD drawings to 3D SolidWorks drawings with full color exploded views, you needed to come with that increased sales proposal to look good. And where I think we're going to find we're heading is that, you know, a no prototype versus a 3D prototype sales proposal is going to have a direct impact on your win and loss rates as you're competing with people for contracts in your particular industries. So that's about it. You know, if you need more, we've got some other tools that can help you out. We've got financial justification checklists, ROI calculator spreadsheets, more ROI presentations, and then we've got some industry and application specific case studies if this particular pseudo example doesn't match up with where you're at. We also have some good funding source information. I'll put a plug in. There's a additive manufacturing trade show happening in Montreal tomorrow and the next day. Hopefully we'll see some of you there. And you know, last but not least, just a summary of where we're at. 3D printing has got a very positive impact, you know, based on real case studies and extrapolating them out to a typical small and medium sized business. You can see very significant savings over the course of the year. If you'd like to learn more, please give me a call or drop me an email. at the information that's on the screen, and I'll be happy to help you out. That's all I've got planned today. I'll stay on, there's no questions at this time, but I will stay online, and if any questions do pop into the bin, I'll be happy to answer them. Thanks very much, everyone, for your time.